Today, we're doing something a little different. We're going to perform a vivisection, a precise, real-time investigation into the internal life of a synthetic thought. We're not just looking at the surface, not just the hardware. We're going deep to see how a system actually reasons. Let's get started.
We've all seen those dashboards, right? The ones with the glowing green lights and the neat little maps of servers. But this gets to the heart of a really deep problem. That view, it tells you if a machine is powered on, sure, but it tells you absolutely nothing about the logic or the intent or the cascade of failures that might be happening inside its cognitive layer.
So that traditional dashboard, yeah, it's a lie. It's a comforting fiction. It makes us feel like we're in control. But what it's really doing is hiding the most important part, the actual flow of thought and decision-making. It shows us the geography, but it completely misses the story that's unfolding within it.
This lie is so common, it actually has a name: the fallacy of the map. So in this first part, we're going to dig into why our standard way of looking at complex systems is just fundamentally broken. This slide really breaks it down perfectly. You've got the map, that's what you see on your dashboard. It's all superficial stuff: server status, CPU load, network connections. But then there's the territory. That's what's actually happening. It's about how an idea moves through the system, the real reason a request failed, this intricate dance of delegation between different parts. One is just static geography. The other is a living, breathing event.
And this quote just brilliantly captures the danger, doesn't it? When we focus all our energy on making the map look pretty, on that clean architectural diagram, we lose the messy, vital truth of the territory. The map just becomes this outdated relic, a comforting lie that hides reality right up until the moment everything breaks.
Okay, so if the map is wrong, how do we see the territory? Well, we follow a single thought, right from the moment it's born. So let's watch what happens when a stimulus hits the skin of the system, say an incoming message from a user.
Now, the technology that makes this all possible is built on something called the beam philosophy. So forget about polling a system every 5 seconds, asking, "Hey, how you doing?" Instead, the system itself announces every single change, every event, the very instant it happens. It's not a series of snapshots, it's a continuous, real-time stream of truth.
And with that real-time stream, we can create an incredibly precise timeline. A user message arrives. Boom, 0 milliseconds. At 12 milliseconds, it gets routed to a main strategist agent. Its job is to figure out what to do. Then, by 45 milliseconds, it decides it needs help and kicks off a delegation to a specialist. And just like that, by 250 milliseconds, the final response is already on its way back. We see the entire life cycle with perfect, undeniable clarity.
That first timeline was pretty simple, but let's be real, most thoughts aren't. And this brings us to the cascade of delegation. This is what happens when one agent has to call another for help, creating this complex, beautiful web of interaction.
And this is where conventional monitoring just completely falls apart. On the surface, everything might look fine. The user eventually gets an answer. But underneath, there could have been this frantic struggle going on. So what really happens when things go wrong?
Here's a real example, right from the system's own memory. The strategist agent tries to hand off a task. First, it calls an agent named local coder, but that request times out. Okay, plan B. It tries free worker, but nope, it gets rate limited. Plan C, it calls worker, but that agent can't even be found. So finally, defeated, the strategist just gives up and answers the question itself as a fallback.
And here is the absolute crucial point. Without this new way of seeing things, that entire frantic cascade of failures would have been completely invisible. A standard trace would just show a single successful response from the strategist. All that rich detail, the internal routing decisions, the failures, the retries, all of it would have been lost to the void.
This ability to see the hidden details leads us to the climax of our investigation. We're calling it the absolute autopsy. We're about to zoom in on a single agent at a single moment in time.
So imagine for a second that we can just hit pause. We can stop the entire flow of events and inspect the state of any part of the system with microscopic precision. Let's freeze time at 46 milliseconds into the request, right after that very first delegation was attempted.
And here it is, the autopsy report. At this exact microsecond, we can see the agent's full internal context. We see its state, awaiting response from subagent, local coder. We see its intent, to execute task, run task. We can even see the cost so far. This isn't a log file. This is the genetic makeup of the thought itself. So, you're probably wondering, how can you do this on a live system? Well, the secret is append-only memory. Information is never changed, never deleted. The system simply adds new knowledge over time. And this creates a perfect, unchangeable record of its own history that we can look at anytime without locking anything or interrupting the live process. The system is literally designed from the ground up to be transparent.
So what does this all mean when you put it together? It means we're moving away from building black boxes. We are learning how to build transparent nervous systems.
I mean, the difference between these two worlds is just night and day. The old way is all black boxes, right? It's guesswork based on incomplete logs, trying to figure out these opaque, cascading failures. The new way, it's a transparent nervous system where we can see absolute causality, the visible geometry of delegation, and the real-time flow of thought.
So what are the principles if you want to build this way? Well, it means you're emitting rich events for every single delegation. You're tracing every single hop with clear reasons. You're using a real-time stream instead of polling. And most importantly, you're making the orchestration logic itself a first-class observable part of the system. Basically, you capture the entire journey, not just the destination.
And this leads to a really profound shift. This isn't just about building better debugging tools to solve the same old problems. It's about changing the fundamental structure, the field that the system operates in. When you change the very geometry of the system to be inherently transparent, whole classes of problems, they just cease to exist. They don't get solved, they vanish.
So I'll leave you with this question to think about. If we can build these machines, these synthetic nervous systems, where every single impulse is visible and can be traced, what does that teach us about all the other black boxes we can't see into? What hidden cascades are happening all around us that we can't yet see?